Okay, guys. So yesterday we started talking about surface area, and we talked about the basics, right? We were working with just the boxes, and it doesn't get any harder. We just have to pay attention to what kind of shape we're working with, in the question they're asking. So um, we're going to go with the next shape in the mix today. And just to remind ourselves, right, we have, we're going to call it surface area still. Okay, so this is day two, surface area. We had LA, which was lateral surface area. And it was just the sides. Okay, so very important, right? We recognize when they ask us about whatever it is they're asking us about, are they talking about just the sides of the object? Or, right, are they talking about all of it, which is what we would consider total surface area? And it'll be explicit in the text to tell you what to include. So, are they talking about painting the walls of the room? That's our example for lateral area, right? We only paint the sides of the box. Or are they talking about, right, something where you would cover the entire object, all the sides? And so total surface area is, um, paint everything. All right, we're just going to coat the entire object, all the sides, everything. Okay, so very important. We know what they're talking about um, in their example or in their question. Okay, so yesterday we looked at rectangular prisms. Today we're going to continue with prisms, but we're going to look at today triangular prisms. Okay. Triangular prisms. Now, it's very important, right, that you realize they say triangular. Triangular prisms, that means the triangles are the bases. Okay. The triangles are the bases. That's what the name is telling you, right? Triangular prisms have triangular bases. And that's very important. Okay. That's very important because of the way that a lot of times these are drawn. Um, the base is not necessarily the bottom or the top. Okay. In a rectangular prism, that is the case, right? We have a bottom, we have a top, we have a floor, we have a ceiling. Um, but a triangular prism is so named because we have triangular bases. Okay. So very, very important, right? That means the triangles are the bases. So we have to pay attention to how those are drawn. All right. So we'll just go through a couple quick examples so that we can talk about each one. And so we're going to have, um, let's see, example one. All right. And let's go with a rectangle right here in front. Okay. And we'll go this way with it. And then this way with it. Okay. So, um, okay, so we have a triangular prism here. Okay. I'm sorry. All right. So there's our triangular prism. Straighten out some of those sides. And you can see it just kind of looks like maybe a cheese wedge. Okay. Um, and so we have to look at our triangles and we'll put right angle there and a right angle there. And we have to decide like how we have all of these. So we have a, let's see, it's 10 here, it's 9 here. Well, let's see, before that's got to be 8, and then we'll call that one 6. Okay, so 6, 8, 10. All right, and you can see the right triangle, right? Hopefully on the top and the bottom. So again, triangular prism, triangular bases. So we have a triangle on top, a triangle on bottom. Those are our bases. We want to keep track of those. We want to make sure that we know what the edges and everything are. And then we're going to do this one at 3. Okay. So there we have it, right? We have all of our measurements and we can work with it. Well, this is still a prism. And so we still have the same idea that lateral area, okay, lateral area, we'll answer that, is still S equals capital PH. And our total area or total surface area is S equals PH plus 2B, right? They don't give us anything else for a triangular prism versus a rectangular prism. So how does the same formula work for, different shapes? That seems a little counterintuitive, okay? But it's all because of that right there, okay? Our area for our bases now changes, right? Whereas before we were finding the area of rectangles for our bases. Now we're going to be finding the area of triangles for our bases. So that's where, right, this formula still works. Perimeter is what perimeter is. Height is what height is. And so we can, get those off of any prism, but the area of the base is going to change depending on what kind of shape you have as your base. Okay. So again, if you wanted to, right, you could draw these out. Now, what we have to realize is how many sides do we have? How many faces are there on this? Well, there's this one rectangle in the front. Okay. That is 10 by 3. Okay, there's this one on the side over here. And that one's going to be a little smaller, right? It's 6 by 3. And then we have the one in the back over here. Okay, that is going to be 8 by 3. Okay, so they're all 3, but 8, 6, and 10 are our 3 side lengths. Okay, so we have 30 here, 18 here, and 24 here. Okay, so that would be my lateral surface area. And then I have 2 triangular bases. They're exactly the same, right? There are these right triangles. And those right triangles are 6 by 8 by 10. Okay, so we need to think about how do you find the area of that triangle? Okay, well, that triangle, right, is just 1/2 little b, right? Little b here means the base and the height of this triangle. So if we look at this, right, the height and the base always meet at a 90-degree angle. So these two sides are my base and height. And then this 10 is really not needed, right, to find the area of the triangle. So I would have 1/2 of 6 times 8. Okay, so 1/2 6 times 8, that's 48. Half of that's 24. Okay, and I have 2 of those, right? I have 2 of those. All right, so that one's 24. Okay, so there's all the different sides of my 3-dimensional shape laid out individually. And again, this is the longer way to do it, but the completely okay conventional, like you're just doing things a little bit longer. And so we have our 3 sides here. Okay, that would give us, adding those together would give us the lateral area. And then we have the 2 bases that we could then add to that to get our total, right? Total is all of them. Okay. But, right, we aren't given this approach on our star chart, right, on our reference material. So very, very important that we can work with the formulas. And really they're quicker. There's one step, right? All we got to do is find those two things and just do the multiplication, and we got it. But right, if when in doubt, right, when in doubt, I can do these all as basic shapes for what they are, and then add them together as needed. Okay, so let's just go through the lateral area first, right? Lateral area says capital PH. Remember, the capital P means perimeter of the base, right? So I'm gonna put a little thought bubble there. Capital P is the perimeter of the base. And again, if I know it's a triangular prism by looking at it, okay, or I'm told, then I know the base is a triangle. So I just simply find the perimeter of our triangle. The 10 here matches up here. So that's 10, and then 6, and then 8. So just adding 10, 6, and 8 together would give me the perimeter of my base. Okay, so those three sides right there are going to give me the perimeter. 10 plus 8 plus 6 is 24. All right. So there's the perimeter. And then I just need the height of my prism. And so I simply go and figure out how far is it between the two bases, right? Height is going to be described as the distance between the two bases. So very important, we recognize that as well. So that's a 3, and we simply go, right? 24 times 3 is 72. And we're talking about units right here. So let's throw some units at it. Let's just go with yards. Why not, right? This can be a big, big, big triangular prism, right? So yards, right? That's all yards. So this would be 72 yards squared. All right. That's our lateral area. That's the area of all the sides of our base. And again, we could simply go in and add these two up, three rather. So 30 plus 18, that's 48, plus 24, which is 72, right? So we're on the right track here, whether we do it the long way or the short way. Okay. And then we have our total surface area. Okay. And our total surface area, again, the formula says capital PH plus 2 times that big B, right? The capital B, the uppercase B, and that has to mean something for us. Like, it's not just saying base, it's saying the area of the base. So again, another thought bubble for us here, right? Big B means area of the base. And it seems silly to just keep writing this and talking about it. But right, I've seen this mistake made so many times. I want to make sure that we get away from that, right? Okay. So as before, I've already got this, but just in case, right, we're going straight into the formula. That would be it, right? 24 is the perimeter of the base. The capital P doesn't change. And the height of the prism is 3. So we've got that part, and then we're going to add to that 2 times whatever the area of one of my bases is. And I've already figured that out over here, right? We figured out the area of the triangular base here is 24. So I would put 24. Okay. And then it's just a matter of, going through and doing the math and then adding them together. So we have 72 plus 48. So that's 80. So that's 120, right? And we have square yards again. All right. So there's your total surface area as well. Okay. So 120 yards squared. All right. So I want to do one more example just so that we can kind of see what I'm talking about here. Why do I make such a big deal about these triangles? Okay. And it has to do with how a lot of times these are going to be drawn. All right. So example number 2. we're going to have, right, this guy here, and then we'll come up here and draw this guy like this. All right. Okay, so here is our triangular prism. Okay, and we've got a couple other measurements to add in here. Okay, so this is a 9 by 9 by 9 by 17. And then this is going to be for a 7.8. And we'll use meters. Okay, so that's a 7.8 in there, right? 7.8. And so if you'll notice, right, this one is looks like a tent, right? If you think about kind of your basic tent setup, we've got, right, a front door here, right? Maybe 2 panels, and then you could, be inside there. But right, here's the big deal with these, right? This is a triangular prism, which means the triangle makes the base. So this out front and this in the back, those are our bases, right? I know it is technically looks like it's sitting on this rectangle at the bottom, right? There's a rectangle down here. But that is not a base. That is one of our faces. That's one of the sides. Okay. So we're always talking about, right, in the name, what kind of base it has. And so this is a triangular prism. And so it has a triangular base. Very, very important. We recognize that because it does matter, right? As we go through our formula and try to work. And this one I'm not going to draw out, right? This one, we're just going to use what formulas we're given. So for lateral area and surface area, okay, let's find the lateral area. The lateral area says S equals PH. Okay, so perimeter of our base times our height. Okay, so H is the distance from base to base. All right, from base to base. How far is it, right? How far is it? Very important when we're talking about this H versus the other H. Okay, there's another H in our formula chart. They are the same. They're both lowercase. So let's put our numbers in, right? What is the perimeter of our base? Well, in this case, our base, because it's a triangular prism, is a triangle. So it's talking about the perimeter of this triangle, right? The perimeter of this triangle is 9, 9, and 9. So that's going to be 27. Now, the height here is the height of our prism. We need to make sure that we figure out, right, how far is it from base to base? This height here is the height of the triangular base, right? It's not the height of the prism. Okay, two different things. Two different things. You got to pay very close attention. Okay, so it's 27 times 17, which, right, I don't have a calculator handy for myself, so got to go over here and actually do some math. 49, 14, so 18, and then we got 27, so 9, 15, and 459. Okay, seems okay to me. And so 459, and this would be meters squared. All right, meters squared. So I can answer that one right away. 459 meters squared. Okay, so that's lateral. Okay, and then we can go to our surface area. All right, surface area says, again, capital PH plus 2, well, that's an equal sign, plus 2 capital B. Okay, and right? I already know this, but maybe we didn't find it already. So um, S equals, and that was 27 times 17 plus 2. Now I need to find the area of my bases. And this is where, right, I need to kind of picture what do I got going on here. All right. So this is a base, right? That's a picture of a base. It was 9 by 9 by 9, and this is 7.8. Okay. So, right, I just need to find the area of that triangle. And so I'm going to kind of come over here and do a little side work, and using that formula. It says base times height. So I know the height and the base meet at a 90-degree angle. So I'm going to take 9 and 7.8. Those are my two numbers that I need. So 9 is the base and 7.8 is the height. And all I need to do from here is go ahead and do some math. Okay. So you can do this in any way. You can use your calculator, of course. We can go ahead and get that opened up. Hopefully, if you're online, you're using Desmos. That's our calculator. If you have one of your own, that's fine. Just realize that on the STAR test, right, we're going to have to use the calculator on the computer. We can't use our phone anymore. But I'm going to switch over to that for you so you can kind of see how I would enter it, just to get make things easy on myself. And then we can put all of this in there going forward. All right, so jumping over to Desmos here, and we've got our calculator. And so instead of 1/2, I'm going to use 0.5 because I know those are equivalent. I'm going to put parentheses just like I wrote it and put 9. And it's already trying to do the math for you, but I'll put another parentheses and put 7.8. And there we have it, right? That would be our final answer. This is going to be the area of the base is 35.1. Okay, so we go back in and we write that in our formula. Okay, so jumping back over, right, stop share. We've got, right, the area of the base now written in 35.1. That's the area of one of my triangular bases. Okay, so putting that in, right, so I've got this. Okay, I've got the area of all the sides and the two bases now accounted for. All I need to do is put all this together. And so, again, you can go right back to your calculator and you can do that. Okay. So if you just hit enter here or click in the next one, all we got to do is start typing it in as if it was all there. So 27 times 17, 459. Good. I did that one correctly. And then 2 times, and then 35.1, right? And so I get a total of 529.2. So all of that added together, all of that ran in the formula is 529.2. And these were meters, so meters squared. Okay. So very important, right, that we can recognize what shape is our base. And then we can, we can work the problem as is. But with triangular prisms especially, right, we need to pay attention to, just because, right, they are sitting on that side for this one, right, it's sitting on what looks to be this side down here underneath. We don't want to assume that's the base. Okay. We need to know what the name is of that, and so that we can identify our bases correctly. Okay, because this questioning will definitely lead you to a certain way to work the problem. And unfortunately, right, they're trying to steer you in something like this. When your picture is like this, try to steer you to thinking this is your base. Okay, and then you have, right, these sides. That's not the case, right? This is a triangular prism, meaning, right, we have triangular bases. And this triangle and this triangle are the same. So, right, this would be a 9 by 9 by 9 with 7.8 as the height. If you needed to transfer measurements around, it's a perfectly, right, mirror image of itself. Okay. So if you have any questions, comments, or concerns, guys, please, please, please get with me so we can clear that up. This is not intended to be a difficult step into this unit. It's simply finding the area of simple shapes and combining it because, right, this is what's representing the outside of our shape, okay? We're not talking about the inside of the three-dimensional shape yet. That's coming, and most of you know what we're getting at when we talk about the inside of a three-dimensional shape. So, so far we've got rectangular prisms and triangular prisms. Again, paying very close attention to the name. That's what's going to tell you what the bases are. And if you have any questions, comments, or concerns, guys, let me know. Thanks for your time.